Dear students, now we are going to discuss comparison of amplitude modulation and frequency modulation. Comparison of amplitude modulation and frequency modulation. In amplitude modulation, the amplitude of the carrier signal is varied in accordance with the instantaneous values of the modulating signal. In frequency modulation, the frequency of the carrier signal is varied in accordance with the instantaneous values of the modulating signal. Next, the frequency range of amplitude modulation is from 540 to 1650 kHz. For frequency modulation, its range is from 88 to 108 MHz. In amplitude modulation, the amplitude of the carrier is varied, but the frequency of the carrier remains constant. In frequency modulation, frequency of the carrier is varied, but the amplitude of the carrier remains constant. The bandwidth of the amplitude modulation is twice its modulating frequency. But for this frequency modulation, the bandwidth is twice the sum of del f and modulating frequency. So what is mean by del f? So here this del f is nothing but frequency deviation, which is an important factor in frequency modulation. Here it is simply 2 times the modulating frequency, but here it is 2 times the sum of frequency deviation and modulating frequency. So here the bandwidth is far less than the bandwidth of frequency modulation. It is little bit higher when compared with amplitude modulation. So here the bandwidth is independent of modulation index, but here it is dependent on the modulation index, because this del f is the function of modulation index. So what is modulation index? For this amplitude modulation, the modulation index is defined as the ratio of maximum amplitude of the modulating signal to the maximum amplitude of the carrier signal. Simply we denote like this m suffix a, that is modulation index for the amplitude modulation, that is equal to the ratio of AM to AC. For this frequency modulation, the modulation index is defined as the ratio of frequency deviation to the modulating frequency. So here we can mention that as del f by Fm, where this frequency deviation is equal to Kf into Am. Here Am is nothing but the amplitude of the modulating signal. Kf, it is the deviation sensitivity in frequency modulation. In amplitude modulation, the modulation index value cannot be increased above 1. It should be in the range from 0 to 1. Its maximum value is 1. But in frequency modulation, the modulation index can be increased by increasing the frequency deviation. There is no limitation on modulation index. In amplitude modulation, most of the transmitted power is wasted in the form of carrier power and one sideband. That's why we are having a different types of amplitude modulation in order to save the energy, save the power, like double sideband, single sideband and vestigial sideband. In case of frequency modulation, all the transmitted power is utilized properly. Hence, the transmission efficiency is higher than the amplitude modulation. In amplitude modulation, the number of sidebands is only 2 sidebands are used. Here, upper sideband and lower sideband. In case of frequency modulation, infinite number of sidebands can be produced, The number depends on the modulation index. In amplitude modulation, there is no quiet bands. That's why we are having adjacent channel interference in amplitude modulation. But in frequency modulation, due to the quiet bands, the adjacent channel interference is eliminated. AM receiver has low noise interference. FM receiver has high noise interference. In amplitude modulation, it is not possible to operate more channels on the same frequency range because the bandwidth consumption is 30 kHz. In frequency modulation, it is possible to operate more channels on the same frequency range. Its consumption is 80 kHz. The circuitry of modulation and demodulation is very complex one. In FM, it is a very simple circuitry. Larger area is covered than FM. Here, much lower area is covered. This is the signal diagram of amplitude modulation where the amplitude of the carrier signal is varied. This is the signal diagram of frequency modulation where the frequency of the carrier signal is varied. So this is during the positive cycle, the frequency there is no change, but during the negative half cycle, there is a change in frequency. Applications of amplitude modulation. It is mainly used for video transmission in TV, two-way mobile radio communications. Here, AM broadcasting operates in medium frequency and high frequency range. This is the application of frequency modulation. FM broadcasting operates in very high frequency and ultra high frequency range. It is mainly used for audio transmission in TV, radio broadcasting, point-to-point communications.